And last one, frequency modulation. Frequency modulation says, oh, okay, we will have the different frequency. For example, larger positive one, we will have a high frequency, and negative one, we have a low frequency. So high and a bit low and really low, and then increase. And so that you can feel, okay, we have the different frequency like this. So if we use the figure to illustrate that one, we use the signal to control the frequency. Previously, it's a common frequency, but right now we have varying frequency for different time. If we want to do that, this is a way to have FM. We have a constant, you see, we have a constant amplitude, but we can have a frequency here, the original carrier frequency. But we have the signal through integral so that we have a frequency. All right, why here we have a frequency? Because 2 pi and fc multiplied t, and here we have a t as well. But t as well, here we have the 2 pi and maybe additional positive one or negative one. So we can increase or decrease. And still we can have the constant phase. So this one means constant phase. So we keep amplitude and change. We keep phase and change. But we allow frequency to be different. We have a frequency C already. Originally, we have a frequency, but right now here we will have a term frequency and multiply T. All right. So we have a step. So step multiply this, so we have the varied frequency. Well, so this formula just want to let you feel okay how to have it. If we have this, and then we want to know, oh, what's the bandwidth associated with frequency modulation? We have the well-known way to measure the bandwidth. The bandwidth follow the form 2 multiply b plus 1 multiply f multiply fm. M is the maximum modulating frequency used. And we have these, maybe later you can check this one, orthogonal frequency. And we have a bit ratio. So using the formula, actually you need to check the taskable to have a more detailed description. And so that we have the bandwidth. And this kind of bandwidth we call Carson's rule. Using Carson's rule, that says the current formula, we can estimate the bandwidth for frequency modulation signal. All right, so follow the formula here, we can have that. But by now you can try to use the term, is it true? Carson's rule and frequency modulation. You can try to use Google or ChatGPT. You try to find it. What's the detailed description about Carson's rule? You can try it. So for example, let's try to look up Carson's rule, frequency modulation, and bandwidth. Then what is the result for that? Well, right now I think, yeah, indeed, if you want to have a yuan, for example, yuan material to prepare the final exam, you can use, for example, Google, you can use ChatGPT. Can you find it? Yes, right. And similar formula here. 2 multiply something. And so that you will have the detailed description for you. All right, because you don't have the task book. Previously I thought you can refer to the content of the task book, but finally no. So that's why I think if indeed finally you don't have the task book, you can try to use, for example, AI tool, try to find some details. If so, then I think it's still okay. All right, but sometimes if we have some mathematical description, then same, you try to have some extension using your AI tools. Is it okay? So at least for Carson's rule, I think it's easy to find, right? So you can try to use that way to have the results. So finally, indeed, if you don't have the task rule, maybe this is a way to have the extension for you. My suggestion to you, I mean, okay, I don't have the task rule, I just have the slides. Can you have the possible content? Sure, but you need to have the input to the AI tool, and so that then you will have the reference materials. All right. If you don't have the task rule, I think this is a possible way to have the result, because sometimes, for example, ChatGPT can look up some content for you. So this is my suggestion to you if you don't want to buy the task rule.